So hello everyone, today we are going to learn how to use toolbox in Scilab. So this will cover two steps. First one is how to install a toolbox in Scilab and how to use it. Now let's come to the Scilab console. So this is our Scilab console and this is the module manager atoms where all toolbox from different branches are present. So let us open this. So as we can see, a lot of toolboxes are present under different categories. So for example, if I click on bioinformatics, a toolbox name bioinformatics is present, and if I click on this toolbox name, the information will get published on the right hand side of the window. We can see this is the instructions, and by clicking on these links we can learn more about the functionality of this toolbox. Now let us go back to the main category by clicking on this, and we can see there are lots of toolboxes are present there. Now let us choose one. Let us go to the physics. Now let us choose to the ODE solver. So when I click on ODE solver, we can see the version is 1.0, the author is Manish Joshi, and we can simply what is the functionality of this? ODE solver creates a graphical user interface for finding the solution of an ordinary differential equation using Scilab ODE function. So basically this toolbox is using the Scilab inbuilt command ODE to generate the solution of the ordinary differential equation and then plot the solution. But what is the best thing in this? We can, instead of writing the code for the ODE, we can simply use the graphical user interface GUI, and just by writing our ordinary differential equation, initial condition and the range of x for the plotting, we will solve our purpose of solving the ODE. So all of you, as you can see, I have already installed this ODE solver, so that's why I am getting remove here instead of install. So let us first I remove this, and then I will again install this to show all of you how we have to do the installation of the toolboxes and how we can remove them. So first I will remove by clicking on this. So all of you can see remove is done. Please restart Scilab to take changes into account. Now I will close this window. What is written here? The package ODE solver is currently loaded. It will be removed at next Scilab start. So now I will close this console. I will go to my start window and click on Scilab 6.1.0 64-bit desktop. So as all of you can see, the Scilab is opened and the console window is visible. So all of you can see, I will again click on this module manager atoms. So it has opened the my module manager window, and all of you can see right now only one toolbox which is MinGW has installed. So as soon as we open our module manager window, it will show the all the installed toolbox on the right hand side window. Okay, so since we can see only MinGW toolbox, that means currently only one toolbox which is MinGW is installed in my Scilab, and also we can see we are getting here three options. One is update, that means an update is available. Another is remove. We can remove this MinGW toolbox and going back to the previous window. And here it was also written that a new version 9.2.0 of MinGW toolbox is available. So let us go back. So we can see all the installed toolbox will be available here, and by clicking on this toolbox we can get about their information or any update is available. Now let us go back to our ODE solver, which is under the category physics. So OD solver is there. I have clicked on it. I can see the author name, version name, description, what is the functionality of this solver and how it works. Everything is written here. For more details, we can click on this link to get an idea or any functionality which is not written here, to get more details basically. So now all of you can see install button is present here, because now the OD solver toolbox is not installed in my Scilab. So I will click on this link, install. Now the toolbox is installed, but please restart Scilab to take changes into account. So it will be good if we restart our Scilab. So what we will do is we'll close our window and again restart our Scilab. So Scilab has started, and all of you can see here it is showing a GUI for solving ODE. Type OD solver to start the OD solver GUI. Type help OD solver for help. So what is this? Since we have installed the OD solver as toolbox, whenever we open our console, it will get loaded on the console. So we have right now I have installed two toolbox in my Scilab. One is MinGW, which is also started here at the starting of the console, and another one is a GUI for solving OD, which is OD solver, is also starting here. So now let us use this to solve the ordinary differential equation. I will simply cite ODE solver and click enter. So now it will open the GUI for the OD solver. Let us wait for 1 or 2 minutes. Now the GUI solver GUI of the OD solver is opened. We have to write the order of the ODE. So maximum it will take up to 10. That means from first order to 10th order of the ODE it can be solved. Now let us choose first order ODE. Y dash is equal to minus 2y. This is our, by default it is showing this. Y dash is equal to minus 2y is the first order ordinary differential equation. By default, when we will open the window, it will show this. Now I will take x naught is equal to 1, which is the initial value of x, and y bracket x naught is equal to 1, which is the initial value of y at x is equal to x naught. Now what we will take, first we will write x. So I want to plot this my solution within the range from 0 to 5. So 0 will be the starting point, 5 is the end point, and 0.01 is the step size. Okay, so now I will click on the solution. So all of you can see it is calculating the solution, and now the solution is plotted in the right hand side window. Now if I want data of this graph, I will click on this show data table, and we can see the data points are here. Now let us choose another one, second order differential equation. Now what will we can see here, y double dash is here. Now I will take only y double dash is equal to minus 2y. I will not change any other thing. Simply in case of first order, I have taken y dash is equal to minus 2y. Now I have taken y double dash is equal to minus 2y. Now you can, all of you can see x naught, which is the initial value of x, y bracket x naught is 1, and y dash bracket x naught is 1. That means the initial value of y and y dash at x is equal to x naught will be 1. I have chosen initial values 1. I can choose 0 also. So let us choose 0. Again, now we will plot x from 0 to 5. We just plot the solution. So first I will clear the data table, and then I will plot the solution by clicking on the solution button. So it's calculating, and all of you can see we are getting 0. Now let us modify the equation and again click on the solution. So we can see what we are getting is a straight line from 0 to 5. Let us increase the range. So again we are getting the straight line. So let us simplify this. y double dash is equal to -2, and initial value of y will be 0 and y initial value of I dash will be 1, and we are keeping the same 0 to 10 with a step size of 0.01. Now click on the solution. So we can see we are getting a graph here for the solution 0 to 10. Now we can change our range. We can plot this as -15 to +15. So let's see what we will get. So we can see we are getting a parabola type curve here. In this case of when y double dash is equal to -2, we are getting a curve similar to parabola. So this is one of the toolbox which is available in the module manager Atom, which we can use to solve first order ordinary differential equation, second order ordinary differential equation, and it can be able to solve up to 10 degree. So this is a very beautiful tool one can use to solve the ordinary differential equations up to the order of order 10. Now let us choose another module, another toolbox by clicking on the module manager. So let's choose physics is there. We have already done physics. Let us choose one more model. We will click on projectile. What will it will do? Projectile creates a Scilab graphical user interface for projectile motion by providing initial values of the angle of projection, speed, height and acceleration due to gravity. It will calculate the time of flight, maximum height, maximum range, and plot its trajectory using comet command. So also you can find the position at any time using the slider. So let us do this. I will click on the install button. So it is installed. Now let us close this window. Again, in order to make the changes, what we have to do is we have to restart the Scilab. So I will close from here. Now I will again go to this. So we can see Scilab has opened. Now it's showing at the startup 3 toolbox, MinGW, OD solver and projectile motion GUI. So what will we have to use? We are now going to use the projectile motion GUI, and for this we have to write projectile to start the projectile motion GUI. So let us write projectile. So as all of you can see, our toolbox has opened the GUI. So I can give initial values or the values of the angle, speed, height and G, and it will calculate all these things. So let us choose angle is equal to 45 degree, speed again 20, height is 0. Okay, so that means we are throwing it from the ground. Now let us click on the launch button. So as you can see, this is giving a projectile motion in real time window. So we can see maximum height is approximately 10. So this is a very good toolbox which we can use to give the demo to our students of the school how a projectile motion behaves. To give a demo which is not possible in the classroom, we can give with the help of this. So we can see maximum range is 40, maximum height is 10 approximately, time of flight is 2.8 seconds. Now let us decrease the angle. Let us make it equal to 30 and let us change the speed 10. Now again we will launch. So we can see we have already plotted one graph for the 5 degree. Now I have chosen the angle 30 and speed 10. So maximum range is 8, maximum height is 1.27 meter, time of flight is 1.09. So this is the second one. Now I have kept angle 30 but now this time I will increase the speed 30, and again I will click on launch button. As all of you can see, this time the maximum height is very large, maximum range is also large, and time of flight, all the things are increases. So this is a very good GUI to give a demo to the students or for yourself how a projectile motion works or behaves on your computer. So I have given the demo of the two toolboxes which are present in our Scilab module manager, and there are large number of toolboxes are available, and we can also create our own toolbox in Scilab which is absolutely free, and you can publish it on the Scilab website also. So if any one of you, if anyone has any doubt regarding the how to use Scilab module manager, how to install a Scilab toolbox, how to use it, one can freely comment in the comment box. I will definitely answer as soon as possible. Thank you.